everyone, it's Olivia here from Olivia's Online Tuition, and today we're going to go through the June-November 2020 Paper 2 EDEXCEL higher tier. So this was a really difficult paper, so if you are finding it difficult, don't worry, we'll go through it all together. It was much harder than Paper 1 for this year, which was my last video. Much harder than that. So if you found that one a bit easy, hopefully this one might be more challenging for you. Feel free to jump around. All the question markers are in the description, so jump around as you please. But yeah, let's get into it. Question 1. Write 84 as a product of its prime factors. So with that, we need a factor tree. So I always start off with 2 if it's even, if not 3 or 5 will go into it. So 2, and then half of that is 42. So 2 times 42, 84, that's a factor pair. And then half it again, 2 and what is that, 21? 2 times 21. Makes 42, so they're also factor pairs. And then divide this one by 3, so that's 3 and 7. We need to make sure that everything on our branches are prime. So we've got 2, 2, 3, 7, and they're all prime. Prime just means that it only divides by 1 in itself. So like 2, the only numbers going to 2 is 1 and 2. So that's prime. 7, only numbers going to 7 is 1 and 2. So that's also prime. So all these numbers are prime. So then what we're going to do, group the ones that are the same together, because 2 times 2, that's just 2 squared. And then times by 3, times by 7, because product means times. Part B, find the lowest common multiple, LCM, of 60 and 84. So for this, we've already got a factor tree for 84. We need a factor tree for 60. So let's do that. So 60's factor tree is 2 and 30. 2 and 15, and then 3 and 5. All these are also prime. So 2, 2, 3, 5. So then we have 2 squared times 3 times 5. Then the one for 84, that gave us 2 squared times 3 times 7. And then both LCM and HCF, so lowest common multiple, highest common factor, we need a Venn diagram, which is one of these diagrams here, the circly ones with the bit in the middle. So we need one of those. Always for HCF and LCM, we're going to put 60 in one of the circles, 84 on the other. And then we need to look and see, okay, what are the common factors in both 60 and 84? So 2 shows up twice. We're going to put 2 2's in here. And then 3 also shows up in both. We put 3 in there, and then 60, we've got 5 in 60, but not in 84, so that goes in the 60 circle, and then we've got 7 in 84, but not in 60, so that goes in there. And then from there, all we need to do for LCM is times all these together. 5 times 2 times 2 times 3 times 7. For HCF, so highest common factor, it's just these 3 in the middle where they join together. But for LCM, it is all of them, everything in this Venn diagram, all times together. So we do 5 times 2 times 2 times 3 times 7, which is 420. So the answer to this part is 420. Question 2. So this symbol, universal set, is everything between 1 and 10. Every integer between 1 and 10. A is the even numbers and B are the factors of 10. Part A, complete the Venn diagram for this information. Right, let's break all this down. So the universal set essentially just means that all of these numbers, 1 through 10, have to be in this rectangle somewhere. Whether in the circles, out the circles, in both the circles, we'll figure that out in a second. But all these numbers have to be in this rectangle somewhere. That's what that means. Then A, so everything in this A circle has to be even. And then this line means everything in this B circle has to be a factor of 10. And therefore, the things in both of the circle in this middle bit here, the intersection, are both even and factors of 10. And everything in the rectangle, but not in the circles, is neither even nor a factor of 10. So they're neither. Cool, then let's get started. So let's go through these numbers. So 1, that goes into 10, it's a factor, but it's not even. So I'm going to put 1 in B. So that's that one done. Let me just put a dot above it to show that I've done it. 2 is even, and it goes into 10. So that's going to go there. 3 is odd, and it doesn't go into 10. So I'm going to put that outside. It's not even, nor a factor of 10. Then 4 is even, but it doesn't go into 10. So I'm going to put that in A. Then 5 is odd, but it does go into 10, so that's going to go there. 6 even, but doesn't go into 10, so that's going to go there, but it is even. And 7, not even, not a factor of 10, that can go out there. 8, even, but not a factor of 10, that can go in here. 9, not even, not a factor of 10, that can go there. And then 10 is even, is a factor of 10, so that's going to go in there. So that is that. I'm just going to make sure I've not missed any numbers, and no, I have not. So that is part A. And then a number is chosen at random from the universal set, that symbol there. Find the probability that this number is in the set A intersection B. So intersection is everything that is in circle A and circle B. So it's going to be this section, if I colour it in a different colour, this section, oops, daisy, here. So everything in both circle A and circle B, which is this part here. The way I remember it is because there's two main symbols, right? There's this one, and then there's this one. So that means A union B. So that's everything in A, like, or B, so in either circles. And this one, so that one looks like a U for union. This one is the other one, like intersection with an N, intersection. That's like sort of like an N, like an upside down U or an N shape. That's everything in the intersection, which is the middle bit. So that's two numbers. Let me change my colour back to its usual colour. So that's two numbers out of the 10 numbers that were in here. So probability is 2 out of 10. You could simplify that to a fifth if you want to, but you don't have to do it. It's probability. You have to simplify the probability, so you can leave it as 2/10 if you want. So yeah, that's that. Question 3. Carlo puts tins into small boxes and into large boxes. He puts 6 tins into each small box. He puts 20 tins into each large box. Carlo puts a total of 3,000 tins into the boxes, so that the number of tins in small boxes to the number of tins in large boxes is 2 to 3. Carlo says that less than 30% of the boxes filled with tins are large boxes. Is Carlo correct? You must show all your working. This is quite tricky, actually. I had to read through this one a couple of times before I understand what was going on. Because of all the large box, small box, all these tins thrown around. There's a lot of stuff to do. So what I saw first is, so we know that Carlo puts a total of 3,000 tins into the boxes. And we know that the number of tins in small boxes, that's 2 parts. In large boxes is 3 parts. So it's 3,000 tins into small boxes and large boxes. And this ratio tells us how many tins put into small, how many tins are going into large, if that makes sense. So this here, this ratio means there's 5 parts, right? So for every 2 tins he's putting into small boxes, he's putting 3 tins into large boxes. They're kind of going in a group of 5, right? So every time he puts 2 into small, has to put 3 into large. So they're kind of going around in a gang of 5. So we're going to do that is figure out how many gangs of 5 there is. So we're going to do 3,000 divided by 5. How many lots of that 5 we have. And that is going to be, what is that, 600? Let me double check. I think that's right. My mental maths, don't trust myself enough. It is 600. I need to trust myself more. So 600. And then we know there's 600 groups of this 5. So therefore, number of tins in small boxes, that's going to be 2 times this 600. So number of tins in the small, that's going to be 600 times 2, which is 1,200. And then we're going to have number of tins in the large, that's going to be 600 times 3, which is going to be 1,800. Okie dokie then. That's the number of tins in each of these boxes. So then what we're going to use with this is he then puts 6 tins into each small box and 8 tins into each large box. So that's, we can figure out from that is how many boxes of each he's got. We know how many tins are in them. There's 1,200 tins in all the small boxes, and 800 tins in all the 1,800 or tins in all the large boxes. But how many boxes is that? Right, so if he's got 1,200 tins in all the small boxes, then he's got 1,200 divided by 6 small boxes in total, right? So 1,200 divided by 6, that is, I believe 200, but let me have a look. Is indeed 200 small boxes. And then he's going to have 1,800 divided by 20 large boxes. And that is 90 large boxes. Okay, And then, oops daisy, can't see that. Let me move it down a little bit. Oop, it's not the right button. There we are, 200 large boxes. Right, and then Carlos said, no, so lots of things in this question, isn't there? So Carlos says that less than 30% of the boxes filled with tins are large boxes. So we need to find the percentage of all the boxes that he's filled are, what percentage of all the boxes that he's filled are large boxes. So to find percentage, we need to know the total number of large boxes, the total of large, divided by the total number of boxes. So it's like the total, essentially. So number of large boxes divided by the number of all the boxes, then times 100. That's how we do percentages. So that's 90, then divided by 200 plus 90. That's all the boxes all together. So that's 290, then times 100. So let me use my calculator. Oops, daisy. Can't see it. Move that down. Use my calculator for that. So that's 90 divided by 290 times 100, and that is 31%. Or 31.0344827, blah, blah, blah. 31%. I'm going to call it that. 31%. So Carlos says that less than 30% of the boxes filled with tins are large boxes, and that's wrong, because actually 31% are large boxes. So what we need to put then is Carlo is wrong. So this statement at the end is really important. See, loads of people lose 1 mark on this because they do all the working perfectly, then they forget their statement. So you have to actually answer the question they're asking. They're actually asking, is he correct? So if you leave it as 31%, you get 4 marks for that, but but to get 5, you have to say this part. Does that all make sense? Question 4. Complete the table of values for y equals 5 minus x cubed. Right, so we have a table here, and they want to know that for these values of x, what will y be? So we have an equation that to find y, we take 5 and we take away whatever x cubed is. So in this case, we're going to use x is minus 2. So we're going to do y is equal to 5 take away minus 2 cubed. So we're going to substitute whatever value we have into the equation. So then we're going to have y equals 5 take away minus 2 cubed, that's minus 8. So 5 minus 8, that's 5 plus 8, which is 13. So first one is y equals 13. And then, we've done this one for us. How nice of them. So then we've got 0 to do. So 0 cubed is just 0. So that's going to leave us with 5, right? So 5 take away nothing is just 5. And then 1. So y is then equal to 5 take away 1 cubed. 1 cubed is 1. So that's going to be 5 take away 1, which is 4. And then we've got x is 2. So we're going to do y is equal to 5 take away 2 cubed. Y is equal to 5 minus 8, which is minus 3. Part B. On the grid below, draw the graph of y equals 5 minus x cubed for values of x from minus 2 to 2. So all we're going to do here is just plot these coordinates that we've got. So first coordinate is minus 2, 13, minus 2, and then up to 13, which is about there. That's that one. And then we've got minus 1, 6, which is there. We've got 0, 5, which is there. We've got 1, 4, which is there. And we have got 2, minus 3, which is there. And then, looks right, looks like a negative cubic, which is quite good. That's what we wanted. I'm just going to draw a line through all of these points, like that. And that is a negative cubic, what we wanted. So a negative cubic always looks like this. If you've got anything with x cubed in it in your equation, look either something like that or something like that. As a positive cubic. So if this was like y equals 5 plus x cubed, looks like this. 5 minus x cubed looks like this, as it did. So yeah, that's question 4. Question 5. Work out the value of x, give your answer to correct to 1 decimal place. So for right-angled triangles, you're quite limited in what you can do. Right, there's 3 things that can come up with a right-angled triangle. First one, Pythagoras. That's the first thing that could come up. Pythagoras, that's the a squared equals b squared plus c squared equation. Or a squared plus b equals c squared, whichever way around you have it. And that is for when you have two sides, you're missing a third side. So not this one, we don't have one of the sides, but we don't have this side either, so it can't be Pythagoras. Also got an angle, so not Pythagoras. Then we have SOHCAHTOA. SOHCAHTOA. And that is for when we either have two sides and want an angle, we have an angle and a side and want another side, which is the situation we've got here. So we're going to be using SOHCAHTOA. The third one is the area is a half base height. It's the area of a triangle. Those are the only three things that come up when you've got a right angle triangle. And in this case, we're going to use this one. So for SOHCAHTOA, first thing you need to do is label your triangle. So first thing I'm going to label is the hypotenuse. So the way to find that is always the angle, the length, that's opposite the right angle. Always when it's directly opposite. So in this case, the hypotenuse is 178. And then I label the opposite side, which is the one that's opposite the angle that they either give you or you want to find, whichever one. So this one, in case we have one given to us, so opposite to that is this one here. It's the opposite side. And then the adjacent, whichever side is left. It's always labelled exactly like this, HOA, should look something like that. And then what we do is I write out my little list, H, O, and A, and I see what have I got. So I've got something on H, I'm going to put a little tick next to it, so I've got something there. I've got something on O, little tick there. I've got nothing on A, so therefore I'm looking for a part of this acronym that has H and O but not A, and that is going to be this bit here. Do we see? There's a different colour. This bit here, this SO. It's got O and it's got H, but it doesn't have A because Ka has A in it and TOA also has A in it. Don't have A, so we can't use those. Get rid of that. Get rid of that. Using SO. The equation for SO is sine x equals opposites over hypotenuse. And then in this case, x is always the angle in this equation here. So then we'll have sine 34 is equal to the opposite, which is x, over the hypotenuse, which is 178. And then to rearrange this, I want x on its own. So what's happening between what we want to move, which is this, and the x, they're being divided. Do the opposite, so you times this one up there. So then you get x equals sine 34 multiplied by 178. Type that into your calculator and you should get sine 34 times 178, 99.53. 99.53. And it's a wonderful place, that is 99 and a half. And there I have it. Hope that all makes sense. Question 6. A is the vector 3, 4, and B is the vector 5, minus 2. Find 2A minus 3B as a column vector. So column vector maths is easy peasy, right? Easy peasy. It's kind of like fractions, but even easier than fractions, right? So what we do first is, look at this, we need to do 2 times A. So I'm going to do that, 2 times A, just times both of these numbers by 2, all you need to do. So 2A, that is going to be 6 over 8, just times top and bottom by 2. And then B, I need to do 3B, so I'm going to do 3B is 15 over minus 6, just times top and bottom by 3. And then I need to do this minus this, so I'm going to do then 6, 8, take away 15 over minus 6. And then for this, all you need to do, easy peasy, minus top, minus bottom. So I'm going to do 6, take away 15, golly gosh, which is minus 9. So I'm going to get minus 9 up there. Then you do 8 minus 6. That's 8 plus 6, which is 14. So the vector I'm going to get is 9 minus 9, 14. Question 7. The diagram shows a right-angled triangle and a quarter circle. The right-angled triangle ABC has angle ABC equals 90. The quarter circle has centre C and radius CB. Work out the area of the quarter circle. Give your answer correct to 3 significant figures. You must show all your working. Right, so we've got a quarter circle and we've got a right-angled triangle. How are these linked together yet? You may or may not be able to see, but what I'm going to do first is I know I need the area of this quarter circle, right? So I'm going to start filling in the equation just to figure out what exactly I'm missing. Okay, so I'm going to do area of the circle, of the quarter circle, is going to be pi times r squared, and it's just a quarter of it. I'm going to times it by a quarter. Okay, and then what I'm missing from here looks to be the radius. So I could find either this length or this length, but this length's kind of amongst all this other triangle, right? It's where the party is, so I'm going to assume I'm finding this length. And then, thinking back to what I said earlier, with a right-angled triangle, you can only have either Pythagoras, but when you have that Pythagoras, can't spell apparently, so you either have two sides and you're missing a third side, that's Pythagoras Theorem, SOHCAHTOA, and that's for when you either have two sides, want to find an angle, or you have an angle and a side, want to find another side, that's that, or the area is a half base height. So for this, we have two sides, want to find a third side, so therefore that must be Pythagoras' theorem. So I'm going to use that then to find this length here. So Pythagoras' theorem is a squared plus b squared equals c squared. And then c squared, so whichever one you have equals, so you could have organised it like I did earlier, a squared equals b squared plus c squared. Same thing. Essentially, whatever you have on its own at the end of the equal sign has to be the hypotenuse. It has to be the longest side. So in this case, it's C. In this case, it's A. I'm going to get rid of the second one in order to not confuse you. So C has to be the longest side. Other ones, doesn't matter. So I'm going to make 6A, and then this miscellaneous one can be B. Doesn't really matter. So I'm going to get 6 squared plus B squared equals 9 squared. So 6 squared, that's 36. Plus b squared is equal to 9 squared, which is 81. Then I need to rearrange this, get b squared on its own. So I'm going to take this over there because I'm doing the opposite, because right now 36 has been added to b squared. We don't want it to be, so we're going to do the opposite of that to get rid of it. So 36 or 81 minus 36, which is 45. So I'm going to get b squared equals 45. I'm going to get rid of this squared by square rooting it on both sides, which is probably some awful decimal, or 3 root 5, or 6.708203932. Kind of gross. I'm going to leave it as 3 root 5, a bit nicer. So then I know that this length here is 3 root 5, and that is the radius. I'm going to be able to put this in there. So I'm going to get a quarter circle is equal to pi times 3 root 5 squared times 1/4. Then I'm going to type that all into my calculator. So I'm going to do pi times open bracket 3 root 5 close bracket squared times 1/4. And that gives me 45 over 4 pi, or 35.3. And that is the final answer. There we are. Question 8. Tariq buys a laptop. He gets a discount of 5% off the normal price. 5% off, that is a reverse percentage. That's the giveaway. They want to have taken money off, they want to find the normal price, that's the reverse percentage. Tariq pays £551 for the laptop, work out the normal price of the laptop. Right. So Tariq, he's paid £551, and that is the equivalent to the normal price, take away 5%, right? So 100%, that's what it was initially. So 100%, that is the normal price. He's then taken away 5%, and then gotten 95%. So that is how much Tariq is paid. It's paid 95% of the total, right? So then we need to deal with this to find 100%. So what I'm going to do is find 1% first. So I'm going to then divide this by 95, because 95 over 95 is 1. I'm going to add this by 95. Then I'm also going to add on this side by 95. Hope you can't really see the divide sign. I'm going to put it up there. Divide, there we are. And then, so 551 divided by 95 is £5.80. And then I'm going to then find 100%, which is just times by 100. We're going to times by 100 on the other side as well, which is 580. So the normal price of the laptop was £580. And then Joan invests £6,000 in a savings account. The savings account pays a compound interest at a rate of 2.4% for the first year, then 1.7% for each extra year. Work out the value of Joan's investment at the end of the 3 years. Right, so compound interest, always the same equation. You take the amount of money that they're putting into the account, in this case is £6,000, you put in the amount in, times that by like the multiplier. So what we do is we take this decimal and we convert it to this percentage, getting ahead of myself, take this percentage and you turn it into a decimal. To do that, you divide it by 100. So you do 2.4 divided by 100, that's going to give you 0.024. And then this is an increase. So we're going to do, it's going to say it's the same at some point. It's going to be 6,000 times 1. So that's to keep it the same. And then we're going to add this little increase we're going to have. So 1.024. That's always how it's going to look. The 1 is to keep it at 6,000, not make it really small. Because if it was 0 points, it'd make it really, really, really small. And then so if you want to keep it there, and then this adds on just for this bit here. There we are. Or essentially, you can also, if you made this into a percentage again, you'd see that this made it £102 to 102.4%. And by 102.4%. So look at it either way. And then it's just for the first year, so that's to the power of 1. The power is how many years they're holding it there for. And then you times them together, and we get 6,000 times 1.024, and that is 6,144. Then we do exactly the same again, 6,144 times by 1.7% for each extra year. So again, 1 to keep it at this. We don't want to increase it, not decrease it. It's going to be at least this. And then we're going to add on whatever this is as a decimal. So it's going to be 0.17. It's just this, and then 1, 2 divided by 100. Get a 0 in there, 0.017. We're putting a 1 there instead. And then it's each extra year. She's holding it for 3 years. So that's 2 extra years. So she's holding it for 2 years. So put 2 up there. Then you're doing 6,144 times 1.017 squared. And that gets you £6,354.67. That's how much Joan will have. Question 9. Aisha recorded the heights in centimetres of some girls. She used her results to work out the information in this table. Okay. Aisha drew this box plot for the information in the table. The box plot is not fully correct. Write down 2 things Aisha should do to make the box plot fully correct. So, first thing you should always check is, are all these numbers plotted correctly? That's going to be at least one of the reasons why it's wrong, always. Why anything is wrong, why the bar chart is wrong, why the scatter graph is wrong, why the pie chart is wrong, why any type of chart is wrong, why anything's wrong in maths, because something's not plotted correctly. So you check that first. So least height, 142, that looks right to me. Lower quartile, 154, that looks right to me too. Interquartile range, deal with that in a second. Median, 162, median should be there. Silly. So Aisha has plotted the median at 161, not 162. That'd be your first reason. So the other ones are probably going to be right. Oh, well, nothing much to check anyway. So actually, should probably mention that is the min, lower quartile, median, upper quartile, and max. That's what all the lines mean. And then we've been given interquartile range and range. We have not been given the upper quartile and the max. So we need to use these to find the upper quartile and the max to make sure they're plotted correctly. So what we're going to do is for interquartile range, that is upper quartile, take away the lower quartile. Always, always, always. And that is equal to the interquartile range. So the upper quartile, we don't know, leave that there. The lower quartile is 154, and they're telling us the interquartile range is 17. So we're going to add that over there to figure out what that is. So the upper quartile is 17 plus 154, which is 171. And so that's plotted correctly. It is not. She's got 172. So Aisha has plotted the upper quartile at 172, not 171. Don't need to check the max. I'm assuming it's going to be right. So I'll check it anyway. Might as well. No harm done. So least height, that's, range, that's max, take min. That's the range. Oop, you can't see that anymore. Oopsie daisy. Let me move that somewhere else where you can see it. Put it up, put it down here. So max, take min. That's the range. Always, always. Highest, hit lowest. That's the range. Max, in this case, what we're trying to find, take away the min, which is 142, equals the range you're telling us, which is 40. So then the max, add that to that. So max is 182, and that one is fine. So Aisha's done that one correct. But not the median and not the upper quartile. And that will get you 2 marks. Question 10. Simplify 1 over m squared to the power of 0. So this is its own indices rule. So anything to the power of 0 is always 1. So the answer to this, no matter what is in this bracket, is always going to be 1, because anything to the power of 0 is always 1. Then part B, simplify x lots of x minus 4 over x minus 4 squared. So there's a factor of x minus 4, both the top and bottom of the fraction. So I can cancel that out, simplify, get rid of that, get rid of that. So I'm going to be left with 8 over x minus 4. It's the same in both, right? Because this squared, all that means is that, right? So this appears in 2 places, and when that happens in a fraction, get rid of them. And then simplify 3n to the 4 w squared all to the power of 3. Another rule of indices, power of a power is power times power. This is when it's outside the bracket, is power of power. So in this case, we're going to raise all the things that are power in here, times them all the powers by 3. So this 3 here, that's inside the bracket, this one, that's currently power of 1. So we're going to do 1 times 3, which is 3. It's not got a power there, it means it's power of 1. And then n to the 4 times 3, that's now n to the 12, that's 4 times 3. We've got w squared, so w, which is 2 times 3, so that's w, w to the 6. And then all we're going to do is 3 cubed, which is 3 times 3 times 3, times 3, which is 27. So we're going to get 27 n to the 12, w to the 6. And that is that. Question 11. Jack is in a restaurant. There are 5 starters, 8 main courses, and some desserts on the menu. Jack is going to choose 1 starter, 1 main course, and 1 dessert. He says there are 240 ways he can choose his starter, his main course, and his dessert. Could Jack be correct? You must share how you get your answer. So this topic here is called product rule for counting. And it always goes kind of the same way. Normally someone's in a restaurant, they're trying to figure out how many options there are. Or it's a code, trying to figure out how many code combinations there are. Or it's, you have a certain number this and this and this, trying to figure out how much you could have all together, right? Product rule for how many like different variations of the things you could choose. Product rule for counting. So all we do here is multiply them all together, and that'll give you the total number of options you can pick. Always the case. So here he's got 5 starters, he's got 8 mains, and he's got a miscellaneous number of desserts. Let's call that X, random number of desserts, and that is going to equal 240. So all those options multiplied together is the total number of choices of 240. And then Jack's going to be correct if this x is a whole number. So you can't have half a dessert. So I mean, you can if you share, but you can't order half a dessert, right? You can't order 0.1 of a dessert, or can't order 2/5 of a dessert. So if this is a whole number, then Jack's going to be correct. So what we're going to do here, we're going to do 5 times 8, which is 40. Just simplify a little bit. 5 times 8, 40. Then times by x, 40x is 240. And then if 240 divides by 40 perfectly, then Jack's going to be right. So let's try that out. 240 divided by 40, which is 6. So there are 6 dessert options. So is Jack correct, or could Jack be correct? Yes. Remember, if they ask you a question, you need to answer it or you're going to lose a mark. In 2-mark question, half your mark's gone. Not good. So make sure you're always answering their question. Question 12. The graph gives information about the volume, V litres, of petrol in the tank of Jim's car after it travelled a distance of d kilometres. Find the gradient of the graph. Okay. So gradient is always change in y divided by change in x. This triangle here just means change in. You'll see it in chemistry, in physics, in maths. See it everywhere. This triangle just means change in. Okay. First thing I'm noticing is this gradient is a negative gradient, right? It goes from top left to bottom right. So I'm going to put a negative here before I even find the number, so I remember, otherwise I'm going to forget. So I always put a negative there as soon as I notice that it's a negative. And then what I'm going to do is I'm going to draw my little triangle lines to help me see the change. And most of it just from the axes. So it meets at quite nice places. I'm going to do it from there. Okay, so change in y, that's from 0 to 25, 26, 27. So that's 27 up there. And then the x is from 0 to 300. So that's down there. So the gradient is going to be 27 divided by 300. And that is 0.09. So I'm going to get as my answer negative, which I've already put there, 0.09. There you have it. And then part B, interpret what the gradient of the graph represents. Okay, so the gradient of the graph tells us the volume of petrol consumed per kilometre, right? It can't be per distance, because if it was any unit of distance, it'd be different, right? If he was trying to figure out how much volume he used per mile, it'd be different to a kilometre. How much petrol he used per centimetre, much different to a kilometre, right? So it's going to be, it's going to say how, or hang on, rate of change, use a fancy term, rate of change of volume per kilometre. There you have it. Rate of change of volume per kilometre. Could put of distance travelled, but this does the same thing. So there we are. Question 12. Question 13. Here is triangle ABC. Work out the length of AB. Give your answer correct to 1 decimal place. Okay, you want to work out the length of AB, so that's going to be this one here. So, for a non-right angle triangle, you've got 3 options. You have either got A, the cosine rule, B, the sine rule, or C, area is a half A, B, sine C. Those are the only 3 things I can get you to do with a non-right angle triangle. So, let's have a look. So cosine rule, that works in 3s. So you either have all 3 lengths and you want to find an angle, or you have 2 lengths and an angle, want to find the 3rd length. That's the cosine rule. The sine rule works in pairs. So you'll have 1 pair of like both the angle and the opposite side fully, then you'll have a half pair. So you'll either have the angle or a side that you know, and the opposite to that will be something that you want. That's the sine rule. And then area is a half AB times C, is for the area. We don't want that, so we're going to get rid of that one. So the sine rule, so that's what we're in pairs. Pairs mean this. So as of right now, that would be a half pair, and that would also be a half pair here. Won't be the cosine rule because we want this length here, and for that we need the other 2 sides. We don't know this one. Can't find this one. So it won't be the cosine rule. So we must somehow be able to find this angle here for the sine rule. Now, if you might notice, angles in a triangle, still, in no right angle triangles, add to 180. So let's find this angle here. Maybe a different colour, actually. Put it in yellow. Find this angle here, which is going to be 180 minus 26 minus 34. And that there then is 120. So now I have one full pair in A and 23.8, and I have a half pair in 34 and X. So let me write out the sine rule. So we have got the sine rule is A over sine capital A equals B over sine capital B. It is technically also C over sine capital C, but I don't like that. I don't like sine over capital this one bit, this part here. I always get rid of it. There's no need for it. Don't need 3, you only need 2. You can just choose anything you want to be these lengths. Doesn't really matter. It doesn't have to be A and B. Like the actual lengths A and B, like in this case. Technically we've got C in here. We've got this C angle, but it doesn't matter. So I'm going to choose, let's go with A as A. So we've got 23.8. So the lowercase are always the lengths. So 23.8 over sine of the angle that's at A, which is 120, equals B, which is going to be this X here, over the one opposite to which I know is angle C, but it doesn't matter. You can call it B. We'll just rename it. There we are. That makes you happy. And then over sine 34. And then from here, we want X on its own. So we're going to rearrange to get X on its own. So we're going to times that up there. So then we're going to get X is equal to 23.8 over sine 120 times sine 34. So you type that into your calculator, just as it is there, fraction times that. And then, let me know what you get. So we've got 23.8 over sine 120 times by sine of 34, which is 15 points, one decimal place, 4. 15.4. And that was the sine rule. Question 14. Here are two squares, A and B. The length of each side of square B is 4 centimetres greater than the length of square A. Okay, the area of square B is 70 centimetres greater than the area of square A. Find the area of square B. Give your answer correct. 3 specific figures, blah, 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 blah. Okie dokie then. What a load of words. Right. So let's break them down. Let's look at them individually. So the length of each side of square B is 4 centimetres greater than the length of each side of square A. So let's write a bit of an equation for that so we can kind of see what's going on with a little more maths instead of keep looking back at this whole load of words, right? So the length of each side of square A is, or length of each side of square B is 4 centimetres greater than the length of each side of square A. So the length of each side of square B is 4 centimetres greater than the length of each side of square A. That's how I've kind of written that equation. The length of each side of square B is 4 centimetres greater than the length of each side of square A. That's how I've set that up. 4 meaning 4, and then plus meaning the greater part. Then is the same as, is that bit there. Okay, and then next part, let's look at the next sentence, this bit here. So the area of square B is 70 centimetres squared greater than the area of square A. So the area of square B is 70 centimetres squared greater than the area of square A. Right. Okie dokie then. So I've also got, let's put kind of this also on the diagram up here. So I've kind of, if we call A, let's call it X. Why not? Then we know that B is going to be X plus 4, right? So the length of square B, we've called that, or length of square A, called that X. Length of square B is an X plus 4. Okay, and then we want areas. So we want the area of square B, that's going to be X plus 4 times X plus 4, right? A bit of algebra going on. So we're going to have X plus 4 times X plus 4. It's going to be equal to 70 plus the area of square A. It's going to be X times X, which is X squared. Okay, then it's time to expand these brackets here. So we're going to do X times X, X squared, X times 4, 4X, x times 4, 4x, 4 times 4, 16, is then 70 plus x squared. Then I'm going to group all these together, which is going to be x squared plus 8x plus 16 equals 70 plus x squared. Now we've got x squared on both sides, we can get rid of those. X squared are gone. I'm going to move up here a little bit. 8x plus 16 then equal to 70. So what I'm going to do here is rearrange it, get x on its own. Then I need to move this and this. Start with this 16, move that over there. I'm going to subtract it. I'm going to do 70 minus 16, which is 54. So 8x, and then that's going to be 54 to 70 minus 16 to get rid of this plus here. And then I've got x equals 54 divided by 8. Get rid of this, send it down there. And that is then, let's have a look, 6.75. There we are. So then we now know that x is 6.75, but we're not done there. We wanted to find the area of square B. Okay, so we know that the area of square B, okay, so area of square B is 70 plus the area of square A. The area of square A was x squared. X we now know is 6.75. 6.75 squared. So the area of B is going to be 70 plus that 6.75 squared, which is 115.5625. Or to three significant figures, that's going to be 116. 116. Ta-da! That was quite a fun one, actually. You don't normally get ones where you have to make algebra like this all the time. Quite enjoyed that. How do you feel about it? Because they are quite tricky sometimes. You get like confronted with all these words, right? You try and pick them out and figure out what they all mean. But yeah, let me know how you feel about that one. But anyway, let's move on. Question 15. Describe fully the single transformation that maps triangle A onto triangle B. Right. So it's question 15, and that is important, right? So all transformations apart from one are foundation, right? They can come on a high paper, don't get me wrong, but they're like grade 5-ish, right? And if they're grade 5-ish, they ain't going to be question 15. So those include translations, enlargements or positive enlargements, rotations and reflections. They're all grade 5. They can come up, but not a single transformation, right? There's normally multiple, you have to do it once in order if they come up. The only one that's not grade 5, one that's grade 6, is negative enlargements. So that's one way you can spot that it's a negative enlargement, because it's question 15, not question 6, right? So we know that it's a negative enlargement, probably without even looking at it. Negative enlargements. But you can look at it, because as you can see, it's kind of been, it looks like a rotation, but it's just, but then it'd be enlarged as well. So when it looks like a rotation and an enlargement, but it's one transformation, and then it's a negative enlargement. Negative enlargement flips it and enlarges it. So what we need for a negative enlargement, we need to know the name of it. Already got that. Check. We then need to know the centre of enlargement. We also need to know the scale factor of enlargement. Scale factor is easiest, so let's do that next. So scale factor, that's just what they've multiplied by. It's going to be, they've gone from, let's have a look, they've gone from 2 to 3. So they must have multiplied it by 1.5. Or negative 1.5 is a negative enlargement. But I've already put negative there, so it doesn't really matter. But I'll put it here. So scale factor by 1.5. And then to find the centre, what you need to do with that is always the same. You connect up the points. We'll connect up this point here with this point there. It's the same point on both of the triangles. That'll be that, and then that will be that, and then, oopsie-daisy. I never know what that happens, you know, it just happens sometimes and not others. Bit odd. There we are. So that there will be the centre of enlargement. Where all the lines cross over, that is the centre of enlargement. So that is going to be to centre 1, 1. And that is a negative enlargement. 2 marks. Question 16. Here are the first 5 terms of a quadratic sequence: 10, 21, 38, 61, 90. Find an expression in terms of n for the nth term of the sequence. So finding the nth term of a quadratic sequence is always the same, right? So for this one, it's one of those nice math topics where you just like learn the method. It's always the same. So the first thing you're going to do is find the second difference. So for that, I'm going to rewrite it just so that I can write underneath it without like writing over the question. But you can write over the question if you like, doesn't really matter. You know what's going on now. And then we're going to find the second difference. So the first difference between those numbers, that's 11. Then that is, what is that, 17? I'm going to double check. Don't trust myself, you see. Really should start. I've got a first class engineering degree, but I don't know how to do 32 and 21. 17, I was right. 61 minus 38, that I really trust myself with. 23, and then 61 and 90. I'm just doing 90, take away 61 for all these. Just whatever the second number is, take away the first, I'll get you the difference. And that's 29. Then the second difference is do exactly the same again. 11 to 17, that's 6. 17 to 23 is also 6. That and that also 6. It should all be the same one for here. And then what we do for this, for the quadratic nth term, just half this number. Always the case. Get whatever number here, half it. So that gives you then 3n squared. Start building up your quadratic nth term. So that's that. And then for this, what we do is you write out your original sequence again, your OG. That's 10, 21, 38, 61, 90. And then you write out the 3n squared. So what we're going to do, we're going to take away this sequence out of the original. So we're just left with regular linear nth terms. So we're taking out, subtracting the bit that's quadratic, right? So 3n squared, you're going to put in 1 into this. So 3 lots of 1 squared, that's 3. Then 2. 3 lots of 2 squared, that's 12. 3 lots of 3 squared, that's 27. 3 lots of 4 squared, is that 64? 3 lots of 16? 48. So yeah, that's why I got just enough. And then 3 lots of 5 squared, that's 75. Okay, then what we're going to do is subtract, so take out the negative. I'll take out, sorry, the 3n squared, so take out the quadratic bit, so we're just left with the linear expression. So 10 take 3, that's 7. 21 take 12, that's 9. 38 take 27, that's 11. You might notice a pattern here, 7, 8, 9, 10, 11, 12, 13, 14, 15, it's going to be a pattern. And then what we need to do here, find the nth term. This is the regular rules, linear nth term for this sequence here. So for that, find your first difference, which is 2, 2, 2. If it's not the same, either here or here, you've done it wrong. And then, so that's going to be then plus 2n. And then to get from 2 to 7, you need to add 5. And that is then your quadratic nth term. Always the same. So you find your second difference, half it, write out your original sequence again, your whatever you got for your n squared sequence, write that out by substituting in 1, 2, 3, 4, 5, 6, 7, how many numbers you have, take them away, and then find the nth term of whatever list of numbers you're left with. And that is quadratic nth term. Always the same, easy mark as long as you remember the method. Question 17. Write down the coordinates of the turning points of the graph y equals x plus 12 squared minus 7. So for finding the turning point after you complete the square, you need to remember, change the sign, keep the sign. So you always change the first sign. So that's going to give you then minus 12. It was plus, but you've changed it to minus 12. And you're going to keep the second sign the same. That sign is minus 7, but you're keeping it, so it's going to be minus 7. So minus 12, minus 7. That's all there is to it. It's always change, then keep. Change, then keep. Change, then keep. Change, then keep. Just keep repeating it over and over and over again until the 6 in here. Change, then keep. Change, then keep. There we are. That's question 17. Question 18. The diagram presents a solid cone. The cone has a base diameter of 20 centimeters and a slant height of 25 centimeters. A circle is drawn around the surface of the cone at a slant height of 10 centimeters above the base. Gosh. The curved surface area of the cone above the circle is painted grey. So many words. Work out the area of the curved surface of the cone that is not painted grey. Right. Give your answer in a multiple of pi. You must show you're working. Okie dokie then. So we want the area of this frustum here. So it's called a frustum, but there's no formulas for frustums. I mean, it probably is. They're going to be really long, really complicated. So in order to work out the volume or the surface area of this, we're going to find the total surface area of all of it. We're going to find the surface area of all of it. Then we're going to subtract the surface area of the grey bit. And that's going to leave us with the surface area of this white bit here. Okay, so first protocol then, find the surface area of all of it, which is then this equation here, how handy of them, pi r L. So what I'm going to do here is we know pi, that's just pi, easy peasy, times by the radius, that's going to be half of this diameter, which is then 10, times by L, which is the slanted height, which in this case is 25. So that is then going to be 250 times that together, pi. Well, so left in terms of pi, so I'm going to leave it in terms of pi. No point timing it in, just to get rid of it later. And then I need to find the surface area of the grey bits. Okie dokie. So that's a smaller one here. So let's see what we're missing. So we've got pi, r, we don't know. L, also don't know. Out of luck, right? But let's have a thing. So radius, that seems complicated. Deal with that in a second. But L, that's quite simple, right? Because all of it's 25, the white bit's 10, so this grey bit must be 15. So these back sides are going to add together, right, to make the same thing. So that must be 15, so L is then 15. Okay, and then R is the reason why this is question 18, not question like 10 or something, right? Because all the rest of it's been quite simple up to this point. It's just this radius here that's the tricky part. That's why it's question 18. So these are something called similar cones for a similar shape, the shape that's just been enlarged, right? The shape that's been made bigger or smaller by a scale factor. So this, the similar cone, the way I spotted it is a cone in a cone. Whenever you have a shape in a shape in my maths exam, be very nervous, be very cautious, because it could be similar shapes, and it normally is. It's a shape in a shape, probably similar shapes. Okay, so similar shapes, we need to figure out, okay, what do I need to do to get from the big shape to the small shape? That's what we need to do to get from this diameter to this diameter. So I can figure that out by using the slanted heights, which I know. So in order to get from 25 to 15, I need to divide 15 by 25. Always the way. Divide it, and then that's going to be 15 over 25, which is just going to be 3/5. So in order to get from 25 to 15, I'm going to times it by 3/5. Briefly to check it, but that will work. 25 times 3/5 will get you 15. And then what we do is do the same thing to 20. 20 times 3/5, that is going to be, I think, 12, but I'll have a little look. 20 times 3/5 is indeed 12. So then the radius of this is then 12. So then the diameter, the diameter of this is 12, so then the radius is 6. Then I've got 6 times 15, which is 90 pi. Okay, so the surface area of all of it is 250 pi. Surface area of just the grey bit, that's 90 pi. We want the white bit, so we're going to do 250 pi. Oop, that's a 0. 250 pi minus 90 pi. And that is going to get us, what is that, 160 pi? Yeah, let me double check. Don't trust myself. As I keep saying, 250 minus 90, 160 pi. And that's question 18. Quite tricky because that similar radius is hard to spot. I only spotted it because I've seen this many times before. The more papers you do, the easier these things will be to spot. Because they come up quite often. It's not the only times it's come up. I have seen it before. It's just not very common. It's quite a niche part of maths. So yeah. If you did spot that, well done, but it's tricky. So yeah, now you've seen it once, hopefully you see it again. Fingers crossed. All right, let's move on. Question 19. A hot air balloon is descending. The height of the balloon, n minutes after it starts to descend, is hn meters. The height of the balloon, n plus 1 minutes after it starts to descend, is hn plus 1 meters. Is given by hn plus 1 is k times hn plus 20, where k is a constant. Okie dokie. The balloon starts to descend from a height of 1200 meters at 9:15 a.m. At 9:16 a.m., the height of the balloon is 1040 meters. Work out the height of the balloon at 0918. Right, this looks really complicated, and they've done that on purpose. They've used really fancy maths notation. Well, not really all that fancy, but more fancy than you used to at GCSE, that's for sure. So all this means is essentially what's happening is when you're going a minute later, the balloon has ascended a certain amount, right? A certain percentage of the balloon is now a certain percentage of what it was before. Maybe 80% of the height it was before, 70%, maybe, 98% of the height it was before, but it's going to be some percentage of the height it was before, right? Some low percentage. So that's what this is telling us. So the new height is some fraction, some percentage of the old heights plus 20, just because they've thrown a plus 20 in there just for good measure, right? So that's what this is essentially saying. So the balloon starts to descend from a height of 1200 meters at 09:15. The times aren't really all that relevant. It's just to show us that it's ascending a minute. Shows how the balloon is ascending, how many minutes have passed essentially. So what I'm going to do is the height at n plus 1. So the height at 09:16, which is 1040, which is the height 1 minute after it started, is then k multiplied by the height that it was originally when it starts to descend. That was 1200 and then plus 20. We're trying to find k here so we can apply it then later on and figure out how much it's descending by, what percentage it is of the total, what fraction it is of what it was before, right? So then what we're going to do is just deal with this. So 1040, I'm going to subtract 20, just get rid of that, move it over there. Get 1020 equals 1200 multiplied by k. Then we're going to divide through by 1200 to get k equals 1020 divided by 1200, which is 0.85. So what's that saying is every minute the balloon is 85% of what it was, the height-wise. So what it's saying is it's losing 15% of its height every minute. So every minute it's losing 15% of its height, right? Roughly, plus 20, with this plus 20. But that's roughly what it's saying. So what we're going to do then is keep working our way until we figure out what 0918 is. So we now know what it is for 0915, 0916, let's do 0917. So the height of when it's 17, 0917, is going to be k, which is 0.85, multiplied by what it was when it was 16, which is 1040, and then plus 20. So that is then going to give us 0.85 times, that's 5, times 1040, and then plus 20, that's going to give us 904 meters. That's going to be 0917. And 0918, so height when it's at 18 when it's passed, 0.85 times 904, so the height it was the last minute, plus 20, which is 5 plus 20, 788.4 meters. So it looks really complicated, but as long as you kind of have a good look at this and actually think about what is it saying, all it's saying is that after every minute it's descending by this kind of amount, right? By whatever this k is. That's all it's saying. So as long as you kind of have a good think about what it's kind of trying to say without getting kind of bombarded with all this weird notation we don't really use very often in maths, then it's not too bad, but it is difficult. It's not easy, this question. It's quite tough as this paper. It's a really difficult paper, I find anyway. I think it's one of the hardest I've seen in a long time. But anyway, Moving on. Question 20. There are only red sweets and yellow sweets in a bag. There are n red sweets in the bag. There are 8 yellow sweets in the bag. Sajid is going to take at random a sweet from the bag and eat it. He says probability that the sweet will be red is 7/10. Show why probability cannot be 7/10. Right, okie dokie then. So, probability is always, probability of red in particular, is always the number of red sweets there are. So the number of the thing you're looking at in the question, whether they're red sweets, yellow sweets, I don't know, golf balls, whatever the context may be, right? Number of whatever it is you're looking at particularly, so number of red divided by the total number of sweets that you can pick. That's probability. So the number of red in this case is n, okay? And then the total is going to be n plus 8. Okie dokie, then we're trying to prove that this is not equal to 7/10. Well, let's put it equal to 7/10 and see what we get. See what n is. Because n can't be a fraction or a decimal, right? Because we can't have like half a sweet or, well, technically, like earlier with Jack's question, you can technically have half a sweet and half a dessert. But in the world of maths, things work in wholes, right? So assuming that all his sweets are intact and they're not broken up, right? So we're just trying to prove that n over n plus 8, that equals 7/10, that n is not a whole number. So essentially trying to prove. So I'm seeing fraction equals fraction. Fraction equals fraction always means cross multiplication. I'm going to cross multiply these times that up there to get 10n, times that up there to get 7n plus 56. Okie dokie. And then all I need to do here is rearrange this just to see what gets get n on its own, essentially. So what I'm going to do here is take this over there. So I'm going to get 10n minus 7n, that's 3n, equals 56. Divide through by 3. N is going to be, I believe that's a decimal, hope so. Divided by 3 is indeed 18.6 recurring. Oops, it is 0.6 recurring. So you can't have 2/3 of a sweet, right? You can't have 0.6 recurring of a sweet. So Jack, not Jack, in this case, Sajid, cannot be correct because n, so you can't have, so what you said here, just answer their question. You can't have 0.6 recurring of a sweet. And that would be 4 marks, 3 marks. There you have it. Hope that all makes sense. Let's move on then. So, after Sajid has taken the first sweet from the bag and eaten it, he's going to take a second random sweet from the bag. Given that the probability that both the sweets he takes will be red is 3/5, work out the number of red sweets in the bag. You must show all your working. Right, so probability that it's going to be red and then red again. So we've already got probability going to be red the first time. That's n over n plus 8. Okay, and then we multiply by, when you're finding two things at the same time, so red and red, you multiply. You then have to take one away from each of these. He's taken out a red sweet already. He's already picked one, already munched one, right? Already eaten it. So we then have one less red sweet than we had before, which is n minus 1, over one less sweet in total than we had before. He's already eaten one. That is then n plus 7. So take one from both these numbers. We've got one less red sweet and therefore one less sweet in total. And that is apparently, they're saying, equal to 3/5. And we're trying to work out what n is, right? We're trying to figure out what n is, because n is the number of red sweets, which we put up here. Number of red sweets. So let me move this down a little bit so we've got some space. You had a whole extra section in the paper, don't worry. This is like very little space for this sort of work. And it is, because you get all this here. It's also 5 marks. So I don't want to bring it all over here though, because I don't want to lose all this top bit up here. So what we're going to do is multiply these together and then deal with this. So let's multiply these first, bring them into one fraction. So multiplying fractions, multiply top, multiply bottom. So we're going to get n times n, n squared, n times minus 1, minus n, over n plus 8 times n plus 7. So that's going to be n times n, n squared, n times 7, 7n, n plus 8, that's n times 8, 8n, and then plus 56, 8 times 7. And that is then equal to 3/5. And then let's simplify this bit down here. N squared minus n over n squared, and then 7 plus 8, that's, what is that, 15, n plus 56, and that is equal to 3/5. Okie dokie. And then again, we've got a fraction equals fraction situation. You can see that, fraction equals fraction situation. So we're going to cross multiply again, just to get rid of both the fractions, times 5 up here to get 5 lots of n squared minus n. Oops. Can't see it anymore. Let's shuffle it over. There we are. 5 lots of n squared minus n is then equal to 3 lots of all this down here. N squared plus 15n plus 56. Okay, let's times all these out. 5 times n squared, that's 5n squared, minus 5 times n minus 5n equals 3n squared plus 45n plus 56 times 3, whatever that is, 56 times 3, 168. Okay. And then from here, this is looking very suspiciously like a quadratic, right? We've got n squareds, we've got n's, we've got numbers. So even if this is a question on probability, quadratics, you got to watch out for them. They can creep up at any time, at any point. Right? Quadratics are always around, all the time, everywhere. Could be probability, could be shape, could be ratio, could be just a number question, could be anywhere, right? Quadratics come up all the time. They love their quadratics. So let's simplify all this in order to get us our quadratic equation. So what we're going to do, quadratics always have to equal 0. So what we're going to do from here is I'm going to make this side equal to 0 because I want to keep my n squared positive. I take this one over here, I'm going to get 2n squared. This over here, minus 2n squared, no good. So I'm going to take all this, so all of that over there. So then I'm going to get, I'm going to move this 0. It's kind of getting in the way a little bit. Okay, so then I'm going to do 5n squared minus 3n squared. That's 2n squared. Then we're going to do minus 5n minus 45n minus 50n. And then take that from nothing, which is nothing, minus 168, which is minus 168. Equals 0. Right, so then I'm going to half all these, because I might as well. Half all them is n squared minus 25n minus, what is that, 84? Let me double check. Divided by 2 is indeed 84. Would you look at me go? 84. And then I'm going to factorise it. I could use the formula, but I think the formula might just be more work at this point. Actually, no, it's not. Let's use the formula. Might as well. So the formula, as you may recall, is x12 equals 2 minus b plus or minus the square roots of b squared minus 4ac all over 2a. So you could factorise it. This does factorise. Or you could use the formula. Either or. Paper 2, you might as well use the formula. Might be a bit quicker. So then, let's put all the numbers in. x12 is minus b, which is 25, plus or minus the square root of b squared, 25 squared. Because remember, a is just the first number, which is 1. B, second number along, which is minus 25. And then C, third number along, which is minus 84. So it's in the same order as the alphabet does. Easy peasy. And then take away 4 times 1 times C, which is minus 84. And then that divides by 2 times 1, which is just 2. And then I'm going to break this up, do a plus 1 and a minus 1 to account for this plus minus here. So then I'm going to type into my calculator, I'm going to type in 25 plus the square roots of 25 squared minus 4 times 1 times minus 84 over 2. And that gives me 28. And then the negative 1, I'm just going to go back in my calculator and delete the minus 1. And delete the plus, sorry. Delete the plus, put in a minus, and that gives me minus 3. So I've then got x, or in this case, technically, actually, n. Get rid of these, replace these with n's, technically. N and n. So they've told us, so that means, let me bring this back up to the question, get back into the context of it all. So we've then got n equals 28 and n equals minus 3. So they want us to find out the number of red sweets in the bag. No, red sweets is n. We've got 2 n's there. What are we going to do? Well, you can't have -3 sweets, right? You can't have negative number of something. So get rid of that. Easy peasy, scrap it. So n is then 28. So Sajid has 28 red sweets in his bag before he eats them. And there we have it. Cool. Hope that all makes sense. Tricky question. Algebraic fractions and algebraic probability, are never easy. But hopefully that made sense. So you mix an algebra out of it, and then essentially just factorising quadratic after then at that point. Cool. Moving on then. Question 19. Question 21. The graph of the curve of the equation y equals f of x is shown in the grid below. Part A. On the grid above, sketch the graph of the curve with equation y equals f of negative x. Right, so what that means is all the x coordinates that are on this curve currently are going to flip. We make them negative versions of themselves, right? They're already negative, make them positive. If they're positive, make them negative. Just flip the sign, essentially. So, let's look at all the points we can find individually, all the nice points. So 0, 0, flip the sign on the 0, it's just still 0, so let's stay as 0, 0. Then we're going to do -1, 2. So we're going to flip the sign on the negative of the x, which is going to be then 1, 2, which is there. And then we're going to do, let's do -2, 1, which is now going to be 2, 1. Then going to do -3, 0, now going to be 3, 0. We're then doing -4, 2, and now 4, 2. So that is what we do. We just flip all the signs, just flip all the signs of the x coordinates until we get something that looks like it's been reflected in the y-axis. They always look roughly like that. So it's going to reflect in the y-axis, which is just changing all the x coordinates to be negative versions of themselves. And that is question 21a. The curve C with equation y equals 5 plus 2x minus x squared is transformed by the translation to give the curve S such that the point on 1, 6 on C is mapped to the point 4, 6 on S. Find an equation for S. Right, so we're moving this graph 3 places to the right. Makes sense? Because we're going from 1 to 4. So it's adding 3, going 3 to the right. So normally, in an everyday translation, that would be 3, 0. Moving 3 places right and none up and down. But transformations of graphs are a little bit trickier. They're a little bit different. So it's what I like to think about it is. So I'm going to call C y equals f of x. I know we've already used f of x up here with this one, but this is irrelevant now. This is a different part. So assume that this is now part C. Just trying to show you what's going on here. So what I'm going to do is I need to move this by 3 to the right. What I always kind of think of it is that x is kind of, when you're moving it to the right, x is going to move it for you, and x is really stupid. That's what I kind of like to think about it is. Anyway, so x is really, really stupid. So if I try to move 3 to the right, it's actually moving 3 to the left. Very silly. So what I do instead is I tell it to move 3 to the left, but it's actually going to move 3 to the right. It's kind of what I wanted to do anyway. So kind of 2 wrongs making a right. So what I'm going to do is tell it to move 3 to the left. It's actually going to move 3 to the right. And that's my mentality. And it may not work for you. You'll need to get something else that works for you, but that's what works for me. Telling it the incorrect way, which will then make it go right, but it's going to go wrong anyway. Does that make sense? It's going to decide to go wrong. It's kind of convoluted, I know. But that's how I've always thought about it. So what I'm going to do from here is, we want an equation. So we want a y equals x squared kind of stuff. So we know that x is being replaced by this x minus 3. That's what I've done in this kind of little section here. I'm just going to replace it with x minus 3 in this equation. That's going to be that's done. So y equals 5 plus 2 lots of x minus 3 minus x minus 3 squared. I could expand it all, but that is not what the marks are telling me to do. I got 1 mark for putting this in, and then, 1 mark for knowing that it's x minus 3, another mark for putting it in. That's my 2 marks allocated and done. You could expand it. You won't get marked down for expanding it, but I'm just going to leave it as it is, and that is done. That's question 21. It's kind of complicated, and there's some really good questions on Maths Uni for this, for transforming graphs. If you are still confused, I can do a video on it, and there's also some really, really good questions on Maths Uni, so I recommend looking at those. It's in the grade 9 section called Transforming Graphs. It's really handy. Feel free to have a look at that. I'll also link that in the description, actually, if I remember. I'll link it in the description too. So there we are. Let's move on. Question 22. Question 22. C is a circle with centre the origin. A tangent to C passes through the points -20, 0 and 0, 10. Work out an equation of C. You must show all your working. Okie dokie then. So the equation of C is a circle, right? So circles always hit the form x squared plus y squared equals r squared. So not forever. If you do A-level maths, then this will not be the case anymore. The equation of a circle is a lot more complicated than this, but at GCSE, the centre, like in this question, will always be the origin, which is just 0, 0, right? That makes the equation look something like that. So this is always going to be the case at GCSE. A-level, it's not. So if you're doing A-level, delete this on your memory but until you do it at A-level, it's going to be different. But GCSE, that's what it's going to look like. So next thing I'm going to do is a bit of a sketch, right? So we can see properly what's going on here. So I've got a circle there. I've got a tangent, which I'm going to put, let's whack it there. I know, oh, that's a curly line. Let's whack it there. And then from there, I've got my centre, which is 0, 0. And I've got my coordinates here. So this, when y is 0, that must be the x-intercept. That's going to be, I know, down here somewhere, -20, 0, and then 0 to 10, that's going to be the y-intercept. It's going to be up here somewhere, which is 0 to 10. Okay, right, so we want to work out the radius. So what you learn kind of from practice is these sorts of questions, when you've got a circle and a radius, they're going to somehow use perpendicular lines at some point. They always do. It's a common thing. They always use perpendicular lines because these two, the radius, which made up the circle theorems, radius means a tangent at 90 degrees, which is a perpendicular line set. So that is 90 degrees. Okay, so what we're going to do now is possibly work out the equation of this line. Then we can get the equation of the radius. Then we'll just know a bit more about it, essentially. And then we can probably end up then working out this point here, which I think is going to be quite helpful. Once we know this point, we'll then know this length, and we'll know this length, right? And that's the axis. That'll be a right angle. Then we'll have our length, Pythagoras Theorem. So that's the kind of the plan. But if you don't know the plan going in, I can kind of see it lay out. But if you can't see it lay out, then just find whatever you can, right? At this point, you only have 2 coordinates. What can you do with 2 coordinates? Find a gradient. Only real thing you can do, right? Let's find the gradient at those points. So gradient is y2, take y1, over x2, take x1, which is then y2, which is 10, take nothing, over nothing, take -20. Which is then 10 take nothing is 10, 0 take 20 is 20, which then gives us, you can't see it anymore, but that gives us then a half. There we are. Cool. So then what we're going to do is work out then the full equation of the line, cuts at 10. So the equation of the tangent is going to be y equals a half x plus 10. That is the equation of the tangent. Let me then change colour. We're going to look at the radius now. So that's the equation of the tangent. Then I want to find the equation of this radius. So what I'm going to do, first find the gradient of it. So the gradients are perpendicular lines. So one is the negative reciprocal of the other. So the gradient of this tangent is a half. The negative reciprocal of that is -2. Put an answer in front, then flip the fraction. -2. So then for the circle, we're going to get, or the radius, we're going to get y equals -2x plus the y-intercept. It cuts at 0, so it's going to be +0. So those are then my 2 equations. And then I want to then find this point of intersection here. Points of intersection, they're found by simultaneous equations. I know, how much is there in this question? Everything. Every topic in the world is in this question, I know. We're going to use simultaneous equations, so we're just going to stick them together, essentially. Do elimination. Eliminate these y's, we're going to get a half, or -2x, equals then this equation here, which is a half x plus 10. So remember, it's intersections of lines, simultaneous equations. Then I'm going to just solve this, add 2x over there, take 10 over there, so I'm going to get -10 is then 2 plus a half, 2 and a half, or 5 over 2x. Then I'm going to do minus 10 divided by 5 over 2, which I'm going to get my calculator to deal with that. Could do it by hand. It's just a key flip change, but my question's long enough as it is. I don't need to add more work than there already is. X is minus 4. Okay, so now we know that x is minus 4 for this point. I can put it into either equation, like I normally do with simultaneous equations. Let's put it into this one, it's a bit easier. Then we're going to get y is equal, y is then equal to minus 2 times minus 4, so y is then equal to 8. Minus 4, that's just 8. So then we know then that this length down here is 8, because that's where this point is on the axis here. This point means 8, so then this length 3 from this is where this is essentially the axis. Let me draw those on actually. I'm mumbling a bit. Apologies for my mumble all the time. So this is essentially the axis. Oh, it's going to be a pain to draw these lines properly. Let me see if I can manipulate it a little bit. Let me see. How can I? Oh, there we go. That looks a bit better. Yeah, there we go. That's like the x-axis, and then the y-axis is looking something. Whoopsie daisy. Like that. Where are we? Looking something. Whoopsie daisy. Looking something like this, but just less, obviously less gross than that. Let me grab it and then move it around a little bit. So that's going to be the y-axis. Okay, so this point up here, because we know it's meets at 8, so then this point up here must be 8. So therefore, this length from the origin, which, see if I expand this line, from the x-axis to the point is then 8, and then same thing along here. Let me change back to red. This length along the bottom here is then minus 4, or 4 is a length. So you're going to flip the sign because it's a length. You can't have negative 4 length. So then that then gives us a right angle triangle with the axis, which is then Pythagoras, the next topic they're including with this question. So Pythagoras is a squared plus b squared equals c squared. It's going to be done on this triangle here. If you can kind of see it form, we've got, that's the right angle there, 8 up, 4 along, and that line there is the radius. So then we've got 8 squared plus 4 squared equals r squared. 8 squared is 64. 8 squared is 64 plus 4 squared, which is 16, which is r squared. 64 plus 16 is 80. So then r squared equals 80. And if you look at that, that is exactly what we need. So we could square root this, which is we're squaring it again anyway though. So then the equation of the circle is, finally, let me write it up here where I've got the last remnants of space, x squared plus y squared equals 80. Or actually put it on the answer line, x squared plus y squared equals 80. And that is done. That was grade 9. That's one of the hardest questions I've seen in a long time. If you can do that question, bravo, well done to you, because that is one of the hardest questions I've seen in a very, very long time. And it reminds me of the last question on like 2017 paper, like the last question on that one, the paper 1, atrocious that one was too, but this one is something else. Like how many topics we had? We had equation of a circle, equation with a tangent, we had gradient of a line, we had simultaneous equations, we also had Pythagoras. 5 topics in one question. Awful question, right? If you're one of the people that sat there, watched it through, you've seen multiple videos, you try and understand it, don't worry, if you can't understand it, you're not going to be alone. There will be, I would imagine, maybe 5% of students possibly got that in the exam, maybe less. Not many will have gotten it at all, not many whatsoever. So if you're one of the people that can't get this question, don't worry, you will not be alone. I could barely get it. It was really difficult. And I've got an engineering degree, so don't worry. Right, and there we are then. That's the paper. So that I found was actually, I thought was a really difficult paper. If you struggle with that paper, then I'm not surprised. That paper was probably, I think, the hardest I've seen in a while. And it was really, really difficult, that paper. So if you could do it, if you get a good grade on it, then really, really well done. That paper was really, really difficult. If you haven't yet, I have made the paper 1 for this year, so go watch that as well if you need be. Much the paper 1 revision, I have also made a paper 1 version. But yeah, Other than that, I shall let you all go. If you have enjoyed, feel free to leave a like, subscribe. It does help a lot. I watch the statistics all the time. So if you do, then I'd be really grateful. But yeah, thank you all so much for watching, and hopefully you tune in for the next one. Bye!